All right, let's look at G1, problem number 2. All right, so we want to use an input box for f of x and the sliders for a, h, and k to demonstrate the transformations y equals a f of x minus h plus k. All right, so let's do that. So I'm going to open up GeoGebra. All right, first we have to define a function. So we type in f of x equals, we can just put anything there. So f of x equals say x or something like that, and hit enter. Right, so it gives you this the graph of f of x. Right, then I'm gonna go to input box. So input box is under here. Right, so input box is click on input box and click anywhere on the graph. So I click here. Right, it says the caption, I'm gonna put the f of x equals, then link object is the function we just defined, f of x. Right, so what's good about this is that it allows the user to change the formula of the function. So if you want a different function, for example x squared, then you would have x squared. So you can kind of redefine the function. Right, if you want the sign, and you can have sine of x. Right, but anyway, so you have that. Then you can do absolute value of x as well. Right, so we have that. All right, then I'm gonna put 3 sliders. So you go here, and the first one is a slider. So I'm gonna put 1. Let's see. I'm gonna put it here. All right, a, and let's see, increment. Let's see. I'll just put 0.1 and apply. All right, then another one, and that'll be. I'm gonna call it h, and the increment is the same, 0.1. And I'm gonna put another slider here, and k, and the increment is 0.1. Right, so those sliders allows us to change the values of parameters. Right, so what we're gonna do is I'm gonna define a function called g of x. Right, then which is going to be a times f of x, x minus h plus k. Right, then if you hit enter. Right, then since a g of x is defined based on f and also these parameters a, h, k, so if you go to the pointer tool and you allow to change the value of a, so see a is vertical stretching or compression, h is the horizontal shift. Right, so I'm going to put shift to 0, then if it set a to be 1, and this is a vertical shift to be 0. So you can see that this is the original absolute value function. But if you apply a vertical shift, it goes up and down. Right, and you can see the formula here. And if you apply a horizontal shift, you can see that it slides horizontally. And this is the vertical compression and the vertical stretching. So you can see that by changing the a value, it changes the stretching and the compression. All right, so this is a good way to demonstrate transformations using a function. You can use a different function. Say if you don't like absolute value of x, you can have say sine of x. Maybe the sine I just did. So maybe cosine of x, then you would have a graph like that. Then you can still apply stretching and shifting, horizontal shifting, and vertical shifting. Right, so that's that. So that's it. I hope that this was clear.